This session is about the factor theorem. Grade E students will be able to use the factor theorem to show that a given linear function is a factor of a polynomial. Grade C students will be able to use the factor theorem to factorise cubics. Grade A students will be able to use the factorised form of a cubic to solve problems. Section 2, the factor theorem, on page 5 of the C2 notes. The factor theorem states that if f of x is a polynomial and f of p is equal to 0, then x minus p is a factor of f of x. Now the reason that this is the case is if your f of x is equal to x minus p times some other function, let's call it g of x, we stick p in, f of p equals p minus p times g of p, well, p minus p is 0, so 0 times g of p is equal to 0. Now the factor theorem is used to break down polynomials into its factors. This can be used to solve equations from a wide variety of real-world contexts including science, economics, and etc. Example 1. Show that x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. So what we need is the x value that makes that bracket 0, which is 2. 2 minus 2 is equal to 0. Stick it into our function, 2 cubed plus 2 squared minus 4 times 2 minus 4 gives 8 plus 4 minus 8 minus 4, and everything cancels down to 0. Now in the exam we would then have to write a statement, so we would say therefore x minus 2 is a factor. Without that comment you would not get the full marks for such a question in the exam, and there will only be 1 or 2 marks for this. Example 2. Factorise x cubed plus 6x squared plus 5x minus 12. Now in the exam we'll generally be given a clue as to what value we should use for the factor theorem. In exercises this may not be the case, in which case we should choose x values close to 0. I tend to recommend that we do it systematically, trying x equals 1, then minus 1, then 2, then minus 2, and so on, until we stick into the function and get it equal to 0. So in this case, sticking x equals 1 in, we get 1 cubed is 1, plus 6 times 1 squared 6, plus 5 times 1, which is 5, minus 12. Add those together, we get 0, so that did work. So x minus 1 is a factor. So then we can use algebraic division to break that polynomial down further. So what do we multiply x by to get x cubed? X squared times x minus 1 gives x cubed minus x squared. Subtracting x cubed minus x cubed cancels, 6x squared minus 6x squared is 7x squared. That's the 5x minus the 12. And what do we multiply x by to get 7x squared? That's plus 7x. Multiplying the 7x by x minus 1, we get 7x squared minus 7x. Subtracting 7x squared minus 7x squared cancels, 5x minus 7x gives 12x. Minus 12 comes down. What do we multiply x by to get 12x? That's plus 12. 12 times x minus 1 is 12x minus 12. Subtracting, we get 0. Now if we didn't get 0 for that remainder, we would conclude that we've made some sort of error and have to start again, either with trying to find the correct factor or correct our algebraic division. So far factorisation is x minus 1 times x squared plus 7x plus 12. Factorising further, x squared plus 7x plus 12 factorises to x plus 3 times x plus 4. That completes the factorisation. Now part B asks us to solve the cubic equaling 0. Since we have a factorised form, it's just like a quadratic. The x values that make the bracket 0 give us our solutions. So we have, in this case, 1, minus 3, and minus 4. Then part C asks us for a sketch. Now this uses the same techniques as we were using back in C1. So we know the x values where it crosses, which is 1, minus 4 and minus 3. It's positive cubic, so it goes up, then down, then up again. From the original cubic, it crosses the y-axis at minus 12. Example 3, we have the same sort of idea. So in part A, we stick x equals 1 in, we're going to get 2 plus 1 minus 18 minus 9, which does not equal 0. Try minus 1. We're going to get minus 2 plus 1 plus 18 minus 9. Doesn't equal 0, so that's not going to give us a factor. Try x equals 2. We get 16 plus 4 minus 18 minus 9. Doesn't equal 0. We try minus 2. We get minus 16 plus 4 plus 18 minus 9. Doesn't equal 0. Try x equals 3. We get 54 plus 9 minus 54 minus 9, which does equal 0. And therefore x minus 3 is a factor. Then we use algebraic division. X minus 3 into the cubic. So what do we multiply x by to get 2x cubed? We get 2x squared. 2x squared times x minus 3 is 2x cubed minus 6x squared. Subtracting, we're going to get 7x squared minus 18x minus 9. What do we multiply x by to get 7x squared? That's 7x. 7x times x is 7x squared. 7x times minus 3 is minus 21x. Subtracting, we're going to get 3x minus 9. What do we multiply x to get 3x? That's 3. 3 times x minus 3 is 3x minus 9. Subtracting, we get 0. The remainder we're expecting. So the factorisation we're going to get is x minus 3 times 2x squared plus 7x plus 3 Then factorising the quadratic, 2x squared will have to be 2x and x, 3 will have to be 1 and 3. If we put the 3 here, we'll get 2x times 3 is plus 6x. Put the plus 1 there, we get x times 1 is 1x, 6x plus 1x is 7x. That gives us our factorisation. Again, part B, the solution to the cubic equaling 0 will be the x values that make the bracket 0, which is, in this case, 3, minus a half, and minus 3. And again, similarly for a sketch, have the 3 places where it crosses, the x-axis from solving, so positive cubic, so up, down, up again, crosses the y-axis at minus 9.